general solution to trig equations. We've already gone through the rules. These are the rules that will appear on your formula sheet. Just doing a few questions from exercise 617. So find the general solution of the following. So just continuing from yesterday, I'm going to do cos of x is, I'm going to do root 3 on 2. So we want to find the general solution for this one. Cos of x is root 3 on 2. So we know what the formula for general solution is. Well, let's just look at our acute angle anyway. What's our acute angle x? Cos of what? Because we've got a cos of 30. That's right. So the acute angle is, and that's what this cos to the minus 1, so that's what this cos to the minus 1 of root 3 on 2 is. It's 30. That's what that bit of the formula represents. It's just the acute angle. So the general solution is just 360n plus or minus 30. That's it, right? That's the general solution. But often in an exam, you're not going to be just asked what's the general solution of something easy like this. You'll get an ordinary question where you have to solve some trig equation, and the last step will say, instead of giving your answer from 0 to 360 or from minus 180 degrees to positive 180 degrees, they'll ask you for the general solution of your trig equation. So it's always a last step thing that we do. We'll do a negative one. So cos x is negative a half. Let's find the general solution to this. Now, I'm just going to do like a little quick sketch. So the first one, it was 30, was your acute angle. Of course, you do 30 and not, you do quadrant 1, wouldn't you? For this one, but cos x is negative a half, your acute angle, you know, is, what's your acute angle? But be careful. It's 60, but it's quadrants 2 and 3. You have to do this 120. You have to do the obtuse angle. All right, so there's no, I know it's 60, but it has to be quadrant 2 because it's negative, all right? So it's going to be 180 minus 60, which is 120. You have to use 120 degrees. I don't want negative cos 60. Like, it can't be negative cos 60. I want the size of the angle, not the cos of it. So you've got to use 120. See how I've said here in the first one, it's 30, because when I go from the positive x-axis to there, it's 30. Well, when I'm going from the positive x-axis to this, it's 60. It's 120. So I have to use quadrant 2. So this is the only time you use an obtuse angle. So if cos is negative, you must use the obtuse angle. So must use obtuse angle if cos theta is negative. So x, your general solution, is 360n plus or minus 120. That's it. That's what we do for those. All right? Now, where we're not just doing like cos x, we're going to be doing sine of 2x. We're going to be doing sine of x minus 30, sine of x on 2, all right? Okay, so basically the process is all the same. Where's your 1 on root 2? Sine is positive, right? Quadrants, 1 and 2. Sine of what? Right, so that 2x acute thing is 45 degrees. Do you know what I mean? Sine of 45 is 1 on root 2. So instead of writing x equals, we write 2x equals. Just that equals, what's the general solution for sine, isn't it? 180n plus negative 1 to the power of n of sine to the minus 1 of alpha. That's the formula. Do you know what I mean? Sorry. This is the general solution. Or x equals or theta equals, it doesn't matter. That's what you'll see on your formula sheet. That's your formula. So what have we got? Can I write theta equals? That's the formula sheet. Fs is the formula sheet. That's what you see on your formula sheet. Theta equals 180n plus that. So that's from your formula sheet. So what do we do? Sorry, I crossed that out. So we've got 2x equals 180n plus negative 1 to the power of n of, what did we say it was, the acute angle? 45 degrees. Now, we have to get x on its own, so you just divide each term by 2. So what's 180 divided by 2? 90n plus, now it'll be that times that, so the negative 1 to the power of n just stays. And what's half of 45? 22.5 degrees. Or you can write it as 45 on 2, but we like to write it as 22.5 degrees. And that's the general solution of that one. Okay. Now, Worms, if I give you sine, I'm just going to do some sine ones. Sine of x on 2 is, so that's 1 there. So I've gone sine of 2x is that. I'm going to do sine of x on 2 is a half. Okay. So how do we do the general solution of this? We know what's on our formula sheet. So what is your acute angle? Yeah, acute angle is going to be 30. It's got to be our quadrant 1. So instead of writing x is 180n plus negative 1 to the power of n of 30, we just write x on 2 is 180n plus negative 1 to the power of n of 30 degrees. But we don't, are we okay with that? So just that angle is 180n plus negative 1 to the power of n of 30. So what do you think we do now to find x? Multiply through by 2. So it's 360n plus negative 1 to the power of n of 60 degrees. All right? Now I'll just do some for tan and cos as well. And I'll have to do some negative ones as well. All right? Actually, I'll do this one. Tan of x is tan of 3x is 1 on root 3. Remember, your general solution on your formula sheet is as follows. 180n plus tan to the minus 1 of alpha. Okay, that's what appears on your formula sheet for tan. So what are we going to do? We don't have, so that's our angle. So 3x is 180n plus tan of what is 1 on root 3? Tan of 30. Okay, so you just write 3x. And now what do? We divide through by 3. 60n plus 10 degrees. Okay. I'm going to do a negative one now with tan. Might do tan of x tan of 2x minus 30, so this is going to be a combination of steps, equals negative root 3. So this one's a bit tricky, but it doesn't matter. It's just tan of that. So I want the acute angle. Which quadrants am I in, by the way? Tan is negative. Tan of this angle is negative. Which quadrants? 2 and 4, but we use the quadrant 4. And what is the acute angle, by the way? 60. So we have to use, so our tan to the minus 1 alpha, we have to use negative 60. Okay? How do you get to quadrant 4? It's either negative 60 or positive 300. We want the acute angle. It's got to be negative 60. So instead of writing x, I write what? 2x minus 30 is, using the formula, 180n plus negative 60. You okay with that? So isn't this just 2x minus 30 is 180n minus 60? Now what do you think I do? You've done this sort of thing before with other stuff. Take the 30, yeah. 180, so it's just 180n minus 60 plus 30. You can't add 30 onto 180n. You're just adding 30, right? No, that example, this is this one. So therefore 2x is 180n what? Minus 30. And now we just divide by 2. It's 90n minus 15. All right? So we've done a tan positive, a tan negative with shifts this time. All right? I'm going to do some causes now. With cos of x plus 30 equals 1 on root 2. Cos of x plus 30 is 1 on root 2. Okay. Cos is positive quadrants. 1 and 4, we use quadrant 1. What's your acute angle? 45. So we have to use 45. So we just go x plus 30 is. Now the general solution, theta is 360n plus or minus cos to the minus 1 of alpha. That's what you'll see on your formula sheet. What's your, so it's 360n plus or minus 45, and you just do what? So we just subtract 30. Oh, be careful. This is not just subtracting 30. So you've got 360n plus or minus 45 minus 30. So you've got to write each one out separately. So it's 360n, take the high road, take the low road. Do you know what I mean? So plus 45 minus 30, comma, take the low road is the minus 360n minus 45 minus 30. So this one is a tricky one. So girls, it's 360n plus or minus 45 minus 30. So you've got to go 360n plus 45 minus 30, 360n minus 45 minus 30. Do you get it? So you're going to get different answers for this one. So it's 360n plus 15, 360n minus what? 75.
Is that with every question?
Only with that cos one because it's plus or minus.
Like,
do you get it?
Yeah, with every cos one.
Yes, with every cos plus or minus. Yeah. All right, I'm going to do another cos with a negative this time, but all right, and the same sort of thing. Yes, so every cos plus or minus. Look, every cos plus or minus only if you've got a plus something. All right, I'm going to do a few more coses, all right? But let's say I've just got cos of 2x equals, I don't know, it's different for this one. Cos of 2x equals negative negative root 3 on 2. It'll be different for this one because there's no plus. How do we just do this one? Which quadrant? Yes, because it's 2 and 4. But, sorry, it's 2 and 3, sorry, not 2 and 4. It's 2 and 3. What's your acute angle? 30, isn't it? So we have to do 150. Right? Remember, for cos negative, you have to put in the obtuse angle. You don't write 30, it's not 30. 30 is a quadrant 1 angle, 150 is a quadrant 2. It's different to saying cos 150. It's not cos 150. It's just 150 degrees, not cos of 150. All right? So, because what we're putting in is just the size of the angle, not the cos with it. So I've got 2x equals, isn't this 360n plus or minus? I go 150. You okay with that? All right, so we have to use the quadrant 2. So now this one we just divide by 2. See, we don't have to, that one's different. But if I did 2x plus 45 or something, I've got to change something. Now I will do one like that. I'm going to do of x on 2 minus 15 equals negative a half. So cos of something is negative a half. Quadrants 2 and 3. Cos of, what's the acute angle? 60. But we have to use the obtuse, 120. So we go x on 2 minus 15 equals 360n plus or minus 120 degrees. Now, what am I going to do first? Add the 15. So x on 2 equals 360n plus or minus 120 minus 15. Now, before I multiply through by 2, I can't... Plus. Yes, it is. So, x on 2, I wouldn't be multiplying through by 2 yet. Oh. Yeah, I think we should separate them and then multiply through by 2. So it's 360n plus 120 plus 15, which is what? Plus 135. And 360n minus 120 plus 15 minus 105. No, is that right? Yeah. 360n plus 120 plus 15, high road. 360n minus 120 plus 15. You got that? Girls, do you have that? And now we just multiply through by 2. 720n plus 270. 720n minus 210. Okay? General solution, we're just going to look at sine x is 1, 0, and negative 1. And we're also doing the same for cos x. Before I start, I'm going to do this 2 ways by sketching. Okay, so here is a sine curve. We're going to do it by sketching and also by using the formula. So, if I want to solve sine x is negative 1, you know that's 0, 180, 360. This would be 720. But what's sine x is negative 1? This one, look, which quadrant, sine is negative in which, sine of what is 1, by the way? Sine of 90. But because this is quadrant 3, it's, I suppose you can think of it as quadrant 3, you know, 270. You can sort of think of it as quadrant 3 if you wanted. If I go like this, you know, I've got 90, 180. It is at 270, isn't it? Sine of 270 is -1. So I could say my acute angle is, now I don't say -70 for sine. What do I say for, sorry, so I've got 90, 180, 270, this is 0 and 360. If sine is negative, normally we go, sorry, to quadrant. We got quadrants 3, 4 and 3. But it's sine of, it's going to be 90 degrees, negative, sine of 270. Do you see sine of 270 is -1? So your acute angle is -90. Okay? Or, because don't you have to do quadrant 4 for it being negative? Your acute, so here is, it's -90 for my acute angle. So x is 180n plus -1 to the power of n times -90. Instead of writing plus -1 to the power of n -90, I just bring this minus here. So it's 180n minus -1 to the power of n times 90 degrees. Because it's plus -90 times that. Instead of plus minus, plus a negative, you just put minus here. So actually we need to go back and just fix up that question from yesterday. In that question that we did yesterday, sine x is -√3 on 2. Our acute angle was -60. So we've got 180m plus -1 to the power of n times -60. Instead of going plus -60, it'll be 180n minus -1 to the n times 60 degrees. Are we okay with that? Instead of having a plus and a minus, doesn't change the -1 to the power of n. Please don't change that. All right? We're okay with that? Sine x is 1. Isn't that 90? The acute angle is 90. So our acute angle is 90 for this one. So x is 180n plus -1 to the power of n times 90 degrees. Now, if we want, we could try it for a few values, and we can try this one for a couple of values as well. If we look at the sine curve up here, where is sine x equals 1? The first one is at 90. And I think the second one is at 360 plus 90 is 450. For sine x is 1. So let's substitute. When n is 0, what do you get? Let's just check.
90.
When n is 0, you get 180 times 0, which is 0. -1 to the power of 0 is 1. You get x is 90. And when n is 1, you get 180. What do you get? You get 90 again. You get 180 times 1, which is 180, plus -1 to the power of 1 is -1 times 90. It's 180 minus 90, which is 90, so you get the same. But what about when n is 2? What do you get? When n is 0, when n is 1, I get 90, so let's have a look when n is 2. You get, what do you get? 360 plus, what's -1 squared? 1. 360 plus 90. Yeah, 360 plus 90 is 450. So that just shows that, yes, it's correct, all right? And I could do the same when sine x, for sine x is -1. I can substitute. I could substitute n is 0, n is 1, n is 2, so on, to see the solutions. Last one is when sine x is 0. Here's my sine curve. What's my acute angle? For sine x is 0, what's my acute angle? Acute angle x is 0. So x is 180n plus -1 to the power of n times 0. Are we okay? Because that's the formula for general solution sine, which is just 180n. Okay? That one you could do without even using the solution, because you can see your solutions are, what are my solutions? 0, 180, 360, so on and so on. 540, 720, and so on. So general solution for sine x is 0. That one's not a difficult one. All right. You could almost do that one by drawing it. Now we're going to do the same for cos 0, 1 and negative 1. All right. So cos of x is 1. Cos of x is 0. And we'll do cos of x is negative 1. We want the general solutions for all those. Just going to do a quick cos sketch because you'll be able to see your acute angle there. Cos x is 1. What's your acute angle? Cos of what is 1? Cos of 0. So your acute angle x is 0. So that's just, isn't this one 360n plus or minus the acute angle, which is 0? That one's just 360n. This one, sorry, that's a mistake. That's 360. That's 180. So, but you can see, if you were to write out all the solutions for cos x is 1, you'd get x is 0, x is 360. When would the next one happen? The general solution, where would it be, the next one? Or the normal solution? Anyone? 0, 360, what's this? 720. Can you see how that fits in with the general formula? When n is 0, I get 0. When n is 1, I get 360. When n is 2, I get 720. All right, what about cos x is 0? Where is my first solution for cos x is 0? Yeah, it's at 90. So my acute angle x is 90 degrees for this one. So we've got x is 360n plus or minus 90 degrees. That one's okay. What about cos x is negative 1? Where is my first? Remember, cos x is negative which quadrant? It's got to be a quadrant 2 answer. Where's your first negative 1 for cos x? Cos x is negative 1 for x is? So that's your 180. That's quadrant, on the border of quadrant 2, isn't it? So this one will be x is 360n plus or minus 180 degrees. To the one above it, find the general solution to cos of 2x is negative 1. And I'm just going to do a quick sketch. Okay. Of cos curve. Negative 1. So cos is negative. That's a quadrant 2 acute, obtuse angle that we need to write. So 2x is 360n plus or minus what? When's the first time you get negative 1? 180. Now what do I do? X is? What do we do? Divide by 2. 180n plus or minus 90. Okay? Worms, if I asked you to solve cos of x on 2 is positive 1. Here's another one. One last one. Cos of x on 2 is positive 1. How do we do this one? General solution for this last one. When's the first time you get positive 1? 0? Yeah. So x on 2 equals 360n plus or minus 0. So what's x? 720n. Oh. Yeah. So we want the general solution to tan of x is 0. Tan of x is 0. Here's the tan curve. Remember that it repeats every 180 degrees. When is the first time tan of x is 0? That's the tan curve. 0. So your acute angle x is going to be 0. So this one's not hard at all. It's just 180n plus, you know how it's plus 0, which is 180n. Now, if you sketched it, you could see it repeats every 180 degrees, the tan curve. So sometimes with ones like that, you could almost sketch it and see it. But we're just using, remember the formula is 180n plus that acute angle. All right. I can do one more. Tan of 2x minus 45 equals 0. One more of these. So again, your acute angle will be 0 again, right? All good? So what do we do? 2x minus 45 is 180n plus 0. Now what do I do? Maybe, can I make this 30? I just don't want any halves. I'm making it 30. 2x minus 30 equals tan of 2x minus 30 is 0. So 2x minus 30 is 180n plus 0, because that's your first acute angle, 0. Now what do I do? 2x equals 180n plus 30, and x is 90n plus 15. Okay? So don't get stressed out if you're seeing all funny things here. It's just, that's your theta. All right? Question 7 in your textbook, you can also see questions like this. So find the general solution to the following. Sine of 3x equals sine of 90. Now, when they give it to you this way, they've actually given you the acute angle, because you tell me what, instead of writing sine 90, what does sine of 90 equal? So that's really the same as giving you the question sine of 3x equals 1. All right, so if you see a question written like that, but remember, we want a general solution. Please don't just tell me that x is 30, because, yeah, x is 30, that's my first solution. But it's not my general solution. So if they give you a question like this, it's the same as saying sine of 3x is 1. Now, you know, they've actually given you the acute angle. See, the first time you get 1 is 90. So it's 3x equals, what's the general solution? 180n plus. So like I said, if they give it to you in this format, they've actually given you the acute angle. All right? Because sine 90 is 1, it's really just like solving that. Plus negative 1 to the power of n times, what's your acute angle? 90. And now what do we do? Yeah. So we divide by 3. So x is 60n plus negative 1 to the power of n times 30. Are we okay? So sometimes you might see them like that.